this example is unique because it's actually less work than solving for equations given 2 points, because the slope, we do not have to solve for slope in this particular example because it's given to us. So we're going to write the equation in slope-intercept form, but what we want to do is write the equation of a line that's parallel to this equation, but goes through a different point. So if we look at our equation, you can see that my slope is here. My slope is -9/5. Okay. Now the key word in this example is parallel. Okay. And what we need to remember is that parallel lines have the same slope. Okay. For us to be able to graph two parallel lines that don't intersect, they have to have the exact same slope. So my m is already given to me. It's -9/5. And we're given our point, so we have our x and y value. So we can solve for my missing piece of information, which is my y-intercept or my b. So my y value is -4. My x value is a +5. And I'm going to solve for b. Okay, so the only thing we need to remember is how we multiply a fraction times a whole number. So first thing I needed to do was put it over 1, because when we multiply fractions, we multiply straight across. Numerator times numerator, and denominator times denominator. So when I do that, I get -45 over 5. And I can simplify -45 over 5 because 45 divided by 5 is 9. So this gives me a -9. Now some of you may have recognized that you could cross cancel. And I don't know if every teacher uses that term or not, but what I mean by that is that, so when we multiply straight across, we get one fraction, okay? And you'll notice anything divided by itself is 1. So I could have canceled out these 5s, leaving me with just -9 over 1, which is -9. So if you recognize that, that's great, and that's one less step you have to do when multiplying. So that's just a little side note. And so then to solve for b, I'm going to add 9 to both sides. And I get b is +5. Because +9 minus 4, or -4 plus 9 is 5. So my equation is y equals -9/5 x plus b. Okay, so using the slope already given to me in my equation allowed me to skip that step of trying to find the slope. It's already given to us. And we use that -9/5 because parallel lines require the same slope so they don't intersect. Okay, again, as I have, allow me to show you how to solve this graphically. Okay, so anytime we're solving for equations of a line using the graph, the first thing we always have to do is plot the point that's given. So I need to plot 5, -4. So that's to right 5 and down 4. So there's my point, -5, -4. Okay. Now, parallel line, so I don't have to solve for slope. My slope is given to me. It's -9/5. Okay, so this is my rise over run. Remember, rise is up and down, run is left to right. And you'll notice my 9 is negative. So that means I would have to count down 9 units and then right 5 units because 5 is positive. But if you notice from my point, if I count down 9 and then to the right, I'm counting and moving farther away from my y-axis. So counting that way isn't going to get me the answer that I need. But -9/5 is the same as 9/5, because any negative divided by a positive is still a negative number. So I'm not changing the value in any way. I'm just changing which number has the negative sign. Okay? So when I write the slope like this, I'm going to actually, 9 is positive, so I'm going to count up 9. But my run, I'm going to count to the left 5. And you'll notice from my point, my y-axis is to the left. So that's the direction I need to count in. So I'm going to count my rise up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's my rise. And then I'm going to count to the left 5. 1, 2, 3, 4, 5. Bingo. We have reached my y-axis. And it just so happens it is at +5 on my y-axis. So we had our m. Our m was given to us. It was -9/5. And we counted using rise over run to get my b, which is +5.